This is the well-known Doppler-Fizeau effect from physics, and around 90 years ago, astronomers were able to detect, in fact, and to measure this effect. Around 1925, what scientists expected from this kind of measurements? They expected that some of the spectra will be blue shifted and some of the spectra would be red shifted, because they expected that, in fact, the motion of the galaxies is random. Some are approaching us and some are moving away from the Earth. And that's why, in fact, it came as a very big surprise when, after the measurement of 40 galaxies, it turns out that they all had redshifted spectra. In fact, here there is a very small problem. For 40 galaxies, 39 had redshifted spectra and only one had a blue shifted spectra. I will come back a little bit later to this case. So from 40 galaxies, 39 from Slipher's measurements have redshifted lines. And this was a very unexpected result, because that implied that all the galaxies, in fact, are moving away from the Earth. Instead of having a universe in which galaxies move randomly, there is some kind of global motion of all the galaxies. Now, not only, in fact, if we go a little bit deeper, as we will see immediately, not only the galaxies move away from the Earth, but they also move away from each other, because there is no center of expansion. So this was one of the first major observational moments in the history of cosmology. But another, perhaps equally important discovery came from a very different study. And in fact, this study was done by Hubble, who obtained and who developed a method to measure the distances to the faraway galaxies. By around 1930, this was a major problem in cosmology, as it is still today. It is very difficult, in fact, to measure the distances to very faraway objects. And in fact, the American astronomer Hubble developed a method for determining the galaxies based on the presence of the so-called Cepheid stars. What are the Cepheid stars? Cepheid stars are some pulsating stars. They have a very short, in fact, a very short period of pulsations. It is of the order of days. And this is relatively short, and it can be easily determined. So Hubble was, and because what is important for the Cepheid stars is that there is a very well-determined relation between the period of the star and its luminosity. So if you know the period of the Cepheid star, we can determine the luminosity. If you know the luminosity of the source, we can measure the luminosity of Earth, and from these informations, because they are related by R-square law, one can determine the distance to that star, to that galaxy. So once we are able to find some Cepheid stars in very faraway galaxies, we can, with great accuracy, measure the distances to that object, to that distance. And this is, from the point of view of astronomers, rather easy, because these periods of the Cepheid stars are of the order of days or perhaps of hours, so the observations can take place relatively easily. So Hubble, by using the biggest telescope of his time, was able to detect Cepheid stars in around 40 galaxies. It happened that these are exactly the same galaxies for which Slipher measured the redshift. So he was able, by detecting the Cepheid stars, to determine very accurately the distances to those galaxies. And he also had a very brilliant idea to combine his research with that of Schleifer, with the Schleifer determinations of the velocities of the stars. And doing this simple combination or this simple observation, he made what is probably one of the greatest discoveries in science, and which is represented by this figure. What did he find? He did find that in fact there is a linear relationship between the velocities of the galaxies, inferred from the redshift and their distance. So in fact all the galaxies are receding with a velocity which can be written in terms of a very simple equation. The velocity is proportional to the distance to the Earth, and this constant, denoted here by h, is called the Hubble constant, and this simple equation is called Hubble's law. So because the velocity is usually given in astronomy kilometers per second, and v is given in megaparsecs, so the unit of Hubble's constant is kilometers per second per megaparsec. So this is probably, this simple graph reflects probably what is one of the biggest discoveries ever made in science. It has shown that in fact the entire universe is engaged in some global motion. The galaxies are not moving randomly, but they are flowing away like a river, like the water in a river. The entire universe has an ordered motion. It is in a global motion. Now here there is a of course is the very important question, in fact, especially for people not very familiar with physics. So the question is, if all the galaxies are moving away from us, are we at the center of the universe? Because that would be the first interpretation of this effect. Now, this is not at all correct, and it is easy to prove mathematically. I unfortunately haven't included this proof. But not only we are at the center of the universe, but all observers in the universe may claim that they are at the center of the universe. And the result of this is, in fact, that the universe has no center. And there are many examples of these systems which are growing in such a way that, in fact, there is not a very well-defined center. And one of these examples is the so-called rising loaf of raisins, so a kind of bread. And if we have some raisins in this bread, when it is baked and it grows, all raisins in the bread, in fact, may claim that they are at the center of this process. Of course, there is another question, which I do not know the answer. If the universe has a surface, and if it has a surface, what is happening on that surface and beyond that surface? I don't know. I don't know the answer, and I don't think that there are many very good answers about this. Another question which again is very often raised is about the possible shape of the universe, which again I don't know what is that shape. This is called the problem of the topology of the universe. But anyway, I will be back perhaps a little bit later about these problems. So Hubble have in fact realized that the universe is expanding. Now, after around 10 years after Hubble, a scientist called Lemaitre, in fact, has the following idea. Let's now reverse the sense of the expansion. So let's go back in time. And if we see the expansion in reverse, we see that in fact all the galaxies are approaching each other. And one of the main conclusions of Hubble's law is that sometimes ago, all the galaxies and all of the space-time was